In this video, we'll create sketch splines and slots. After completing this step, you'll be able to create a sketch slot and create a spline. In Fusion 360, we want to carry on with our sketching practice. We've already taken a look at several of the sketch elements, and now we want to take a look at creating some additional ones such as splines or slots. To do this, we're going to start a new sketch on a new plane, but first I want to create an extrude and bring what we've done into 3D. I'm going to bring everything but the center diameter circle. I'm going to bring this up a distance of 50 millimeters. Now that we've brought it up into 3D, the next thing that I want to do is start a new sketch. To do this, I can use one of my planes, or I can use a planar face, such as the top of our extrude. To do that, I simply need to select it, right-click, and create a new sketch. When we do this, it's automatically going to bring this in as a profile. So we can already select these profiles and use them, and the sketch references are going to be there, so we can use the edges and any of the points. But what we want to do now is we want to explore creating splines and slots. So first we're going to go to slot, and we're going to select center to center slot. In order to create a center to center slot, we need to first select a starting point and an ending point, and then we need to drag out for the radius value of the slot. After we do this, you'll notice that some constraints have been applied. There's tangency with the arcs on the ends and the straight sections, and there's a construction line in the center. If we want to align this to any other geometry, I can use the parallel constraint, and I can make the center line parallel with the edge, for example. Once I do that, I can also apply dimensions. For example, if I want it to be 25 millimeters away from the edge, and if I want this point to be a certain distance away, I can say it can be 15 millimeters. Can also give it a radius value, 8 millimeters, and an overall aligned length of 75. Now we've created a fully dimensioned slot. If we take a look at the other create slot options we can do an overall slot, which is simply defined by its extents on its end and its side. We have a center point slot, which instead of going from center of the arcs, we go from the actual center and we go to the center of one of the arcs. Then we also have 3-point arc and center point arc slot. So if we use one of these options, we can grab the center of our large diameter. We can pick where we want that to go, and then we can start drawing it out. Once again, you can see that it's underdefined unless we manually enter those dimensions at the time of creation. If I hit escape to get off the slot tool, I can still move this around, but notice that some of the constraints have been applied. The center of the arc is at the center of our circle, and we fixed it to this point. So the only thing that we can do is we can drag this around and we can change its diameter or its radius value. If we want to add those, we can use our dimension tool. We can manually dimension them, let's say 5 millimeters. And then if we want to give this a specific radius value, it's automatically going to be over-defined because we define this radius value by clicking on this point. So if you want to define the overall sweep of the arc, there's a few different ways that we can do this. We can use our line tool, and we can create construction lines that go from this point over to this point, and then we can use our dimensions to give it an angular sweep value, let's say of 45 degrees. Now we have a fully defined slot, and it's based on the center point of this circle. I'm going to select the construction type to make sure that some of my new lines aren't automatically construction, and I also want to hit escape to get off my dimension tool. I'm going to finish this sketch, and then I'm going to create a new sketch on this side. Now I want to take a look at my spline tool, and there are two different types of splines we should be interested in. There's a fit point spline and a control point spline. Let's take a quick look at both of these. The fit point spline, we're going to start by selecting this end point. I'm going to draw a vertical line up, and then I'm going to begin to bring it over to the left, and I want to go straight up above the origin. Once here, I can hit the green check to create this. I'm going to hit escape to get off my spline tool, and I want to take a look at the controls I have. We created a vertical line with those first 2 points, but notice how this arcs out and comes back. That's because what we're actually doing is we're defining points on the spline, and when we select it, we also have the tangency and the weight or the influence at that point. So, for example, if we want to make it vertical, we can select that green reference line and we can apply a horizontal vertical constraint. We can hit escape to get off our constraint tool, and then we can bring this in. Now what we have is a tangency that is allowing this to start out vertical based on that reference, and then it's going to begin to arc inward. If we want to add or remove points from the spline, we can simply select them and hit delete to remove them, or we can select the spline, right click, and we can insert a spline point. We'll hit escape to get off the insert tool, and then if we select it, once again, we have those references. Now that we've seen how we can create the fit point spline, let's take a look at the difference between a control point spline. To do this, I'm going to start at this point here. Once again, I'm going to draw that second line vertical, and then I'm going to begin to go off to the left, and then I'll hit the green check mark. We'll hit escape to get off of that tool, and notice now the control is a little bit different. Instead of having points directly on the spline, what we have is the control cage on the outside. I can still select this and I can make this vertical, I can make this horizontal, and I can even apply dimensions to these. For example, if I want this to be 50 millimeters and this to be 50 millimeters, I'm going to hit escape to get off my dimension tool. Now I can move these references around. So this is a different way to control a spline. There are going to be benefits to each of these different types of splines depending on what you're specifically modeling. If you need to have some sort of reference, whether it's a coincident or some sort of intersection between a point on a specific spline, then the fit point spline might be a good option. However, if you are trying to control a little bit better the curvature of this spline, then the control in this manner is going to give you a little bit more flexibility. Also, with each of these splines, you'll notice in the sketch palette we can toggle on the curvature comb display. We can do this for either type of spline, and it helps us get a good idea of what's going on with the actual curvature of the spline itself. We can see how changes that we make, for example, moving these points around, are going to affect the underlying curvature. The splines themselves are more of an advanced sketch element. It's something you typically see with complex organic type surfacing. But it is important that we understand what each of these sketch elements are and how we can apply them to our own designs. I'm going to select each of these and I'm going to hide the curvature combs, and then I'm going to finish the sketch. Notice that I don't have a closed region here, but these can be used if we close them as an extrude. They can also be used for things like sweeps and lofts to make more organic shapes. But for right now, let's make sure that we do save this before we move on.